Hi chemists, welcome back to our YouTube channel. Today we'll be looking at the properties of ionic compounds. But before we begin, can you identify the ionic compounds? Pause the video, think about it, and try to identify those substances that are ionic. Now if you stated NaCl, AlCl3, Ki, MgO, then you are correct. These substances are all ionic because they all contain a metal with a nonmetal. Table salt is an example of an ionic compound. The structure of sodium chloride can be represented in the following forms. By the end of this video, you should be able to describe what an ionic lattice is. You should be able to analyze data for the properties of ionic compounds, and you should be able to discuss why seawater is an electrical conductor. An ionic compound is a giant structure of ions. As you can see here, we have two ions. We have sodium ions and chloride ions. These make up sodium chloride. Now, the small black circles with a positive sign in it represent your sodium ions, and the larger circles with a minus sign represent your chloride ions. Now, ionic compounds, they're held together by strong electrostatic forces of attraction between oppositely charged ions. We know that opposite charges, they attract. These forces, they act in all directions in the lattice, and this is what is called ionic bonding. Now, what I want you to do is get a sheet of paper and have a go at describing the arrangement of the ions in the ionic lattice using the keywords here. Okay, now if you get stuck, here's a bit of help. Pause the video and try to use the keywords to fill in the gap in the sentences below. Now, the keywords are electrostatic forces, oppositely charged ions, regular arrangement, and giant lattice. Pause the video, write the sentences down, and try to fill in the missing words. Now, in your response to this question, if you have the following, you can tick it, it's correct, and if not, just fill in the corrections or make your improvements. Here goes. Ionic compounds contain ionic bonds. Ionic bonds are the electrostatic forces of attraction between oppositely charged ions. The oppositely charged ions are arranged in a regular way to form a giant lattice. It is a lattice because there is a regular arrangement, and giant because the arrangement is repeated many times with a large number of ions. As you can see, you have a lot of ions. You have about 6 chloride ions surrounding each sodium ions, and the other way around, you have 6 sodium ions surrounding the chloride ions, 6 chloride ions surrounding the sodium ions. Now, the structure and bonding of ionic compounds can be used to explain their properties. In chemistry, when we refer to properties of any substance, this can be either their physical or their chemical properties. Our focus, however, will be on the physical properties of ionic compounds. Physical properties can include any of the following. They can include hardness, solubility in a solvent. In this case, we're going to be focusing on solubility in water, electrical conductivity, and also melting or boiling point. This is a table with a list of substances. We'll be analyzing the results from a previously conducted experiment investigating their physical properties. Now, in order to analyze the physical properties of ionic substances, there are some key questions that we need to consider. Firstly, which substances are ionic? Pause the video and try to identify which of the following substances are ionic. If you mentioned magnesium sulfate, potassium chloride, and sodium chloride, then you are correct. These substances are made up of both metals and non-metals. Now, our second key question is this: what are the properties of the ionic substances? Now, if you look in the heading at the top of the table, we can see the list of properties. We have hardness, electrical conductivity in the solid state, and electrical conductivity when in solution, and we also have melting point. Now, look at the hardness and compare all these compounds. Look at magnesium sulfate versus paraffin or petroleum jelly, which is not an ionic compound. Compare that to potassium chloride, sodium chloride, and sugar. What do you notice? Now, all the ionic compounds, they are brittle. They're not soft, they are brittle. They are hard, but they are also brittle. If you notice where it says electrical conductivity, all these substances, when they are in the solid state, they can't conduct. However, for the ionic substances, when they're dissolved in water, when they're in solution, they are able to conduct electricity. Finally, for melting point, what do you notice about the melting points of those substances that are ionic versus those substances that are not ionic? Pause the video, think about it, and then write your response down. If you mention that those substances that are ionic, they have a higher melting point, then you are correct. Now, we should be able to explain the properties that we've just described. Okay, we should be able to explain the properties of ionic compounds. Now, the first property that we'll be looking at is hardness. Now, if you look at the compounds that are ionic, they're all brittle. They're hard, but they're brittle. Now, ionic compounds, they're held together by strong electrostatic forces of attraction between the oppositely charged ions. This is why they're very hard. But even though they're hard, they are brittle. Now, the electrical conductivity. Ionic compounds, if you notice, they will not conduct in the solid state. However, in solution, when these solids are dissolved in water, they can conduct. Now, ionic compounds, they can conduct because in solution, they have ions. For example, magnesium sulfate will have magnesium and sulfate ions moving around. Potassium chloride, they'll have this will have potassium chloride moving around. So because of these free ions, a charge can flow. So this is why in solution, ionic compounds, they can conduct electricity. Now let's look at the melting point. The ionic compounds, if you notice, these compounds have a high melting point. This is because large amounts of energy is needed to break the strong bonds within the structure. Due to these high melting points, they're also solid at room temperature. Okay, now we're going to just focus on the melting point of the ionic substances. You should be able to explain why ionic compounds have a high melting point. Now, more energy is needed to overcome or to break the strong electrostatic forces between the ions in the ionic compound. As a result, they have high melting points. Now, the strength of the ionic bonds depends on two things: the size of the ions and the charge of the ions. Now, ions with higher charge will have stronger forces between them. So they will need more energy in order to overcome the forces of attraction. Now, if we look in the table to the left, we can compare magnesium sulfate with sodium chloride and with potassium chloride. If you notice, the ions in magnesium sulfate, these ions have a higher charge than the charges in sodium chloride and potassium chloride. Magnesium sulfate, you have 2 plus and 2 minus for their charges, while with sodium and potassium, you have just 1 plus. Now, another reason why the melting point is very high, it is due to the size of the ions. Now, if we compare sodium chloride with potassium chloride, both compounds have chloride ions. However, the sodium and the potassium ions, those are different. Now, these ions, they're present in group 1 of the periodic table. We'll be looking at this in another lesson. But what I need you to know is that sodium ion, it is larger in size. Potassium ion is larger in size than the sodium ion. So as a result, because you have a greater distance between the potassium and the chloride ions, right, it requires less energy to break these forces. So as a result, potassium chloride has a lower melting point than sodium chloride. So recapping quickly, ionic bonds between magnesium and magnesium sulfate ions are stronger than those between sodium and chloride ions, while the ionic bonds between sodium and chloride ions are stronger than those between potassium and chloride ion. In summary, ionic compounds, they are hard and brittle. Ionic compounds are held together by strong electrostatic forces between oppositely charged ions. They are a good conductor of electricity when molten in the liquid state, or it has been dissolved in water to form an aqueous solution. Ionic compounds also have high melting points or boiling points. A lot of energy is needed to overcome the strong electrostatic forces of attraction holding the ions together.